not working, but I can always point with the mouse for it. Okay, so my name is Jim Kelly, physics professor. I'm happily moved back into Olin just days ago, so my office is in the basement of Olin Hall. Kind of fun to go look around in there. I don't think you're really supposed to go anywhere on the first or second floor at all, but the building is just beautiful. The basement's the least beautiful of it all because it got the least updates. But the second floor and like the lounge areas and the first floor are just wonderful. So it's going to be fun to slowly have people moving back in there, but we're going to be in there for lab. So I'm in room 015. You're always supposed to enter Olin from the Walnut Street entrance, not the front of the building, but the pendulum side that's right by the street. So you're going in the side and go down the staircase that winds around the pendulum. I'm still, my office hours listed on here. There's various things for each day of the week, and I'm not entirely sure of how they're going to work out, so we'll play it by ear. But I've put some extra notes in here because office hours aren't going to be like usual. I think my office looks like it has a capacity of 2, including me. So that means if one student comes by, we could probably sit and talk at the board, but if more than one student comes by, my office will have to move to an adjacent lab, which is great. Our physics labs are right next to my office, so we can just go down there. So if you come to my office and no one's there, look in the adjacent labs, like the lab we have for this class, or the one that's even closer to my office, and you may see a group of students in there. For Zoom people, it's always a little bit awkward because I don't want to have an office hour and then wait for the full hour with Zoom on in the hopes that someone will come to a Zoom office hour. In the fall, I just did it because no one was after my classes. I would just stay in the classroom. People could stay on Zoom and ask questions or stay physically and ask. But I think what I'm going to do is say, for those office hours, I'm going to leave Zoom on for the first 10 minutes. Because my default is if nobody comes, I'm in my office and I'm just doing my work, and it's a good time to work. So if you're on Zoom, my first preference is that you come during the first 10 minutes of the office hour, and then I'm willing to stay on Zoom as long as it takes to answer questions. If that's not working out for you just because of when the office hours are, then certainly let me know and we can schedule other times. I'm always open to scheduling different times. Of course, I can't have a different time for everyone in the class, but if we have a few special cases, it usually works out that way. So I'm going to stick with these office hours at least for the first couple of days, see how it works out with my schedule and your schedule. And if I find a bunch of people really wish it were at a different time that I can make, then I might switch them. So the office hours over there, there's 1 hour each day of the week. Let's see, email and phone is on there. You know, students don't tend to leave phone messages much anymore anyways, but email for me just leaves a record for me. So email me. If I don't get back to you right away that day, I'll try to get back by the next day. Phone messages are just easily lost or forgotten about. The course website, so my course website is not on Google. And actually I had it on Google Sites, and for reasons that aren't worth going into, I changed it to Campus Press just to become more modern here. And so I'm still working out some of the kinks on it, but the link is listed on there. And here I'm just going to click on it and hopefully everything goes well. It opens up the browser. And so you should see something that looks like this. There's kind of 3 columns, not much frills on the website. The left column, so you're going to be doing reading sections in our book. And the book is, that's a little bit lower down on the syllabus, but it's Giancali's 6th edition is what I asked for. The 7th edition is actually fine if you have the 7th edition. It's just more expensive. This one's actually really inexpensive to buy online. And honestly, you know, textbooks, there's a lot of changes between the 1st, 2nd, and 3rd editions, but between the 6th and the 7th, they're just trying to make money by forcing people to buy a new book. So these were available for like $20 or $30, I think, used on Amazon in pretty good shape. So if you haven't gotten one, you should be in the process of doing that now. But I think the bookstore was able to get a bunch of 6th edition ones. So to. When you read some sections, and when you read is going to be shown in the third column here. When you read, you're going to go to one of these links. So one of your first reading requirements is going to be to read sections 2.1 to 2.4. And after you've read it, you're going to click on this link. And there's some sort of lengthy instructions, but you really only have to read them once. They're posted on all these pages, identical instructions. But it's basically giving you instructions on how much of a contribution I want you to make. So what you're supposed to do is tell me things that you found confusing that you want further explanation about, or things that are beyond the scope of what was talked about, but it reminded you of anything either tangential to the course or you think is central to what was being talked about by the author, and you can make a comment. Now, I'm not logged in right now, but if I were logged in, you see the login button up here, you're going to log in with your center credentials. So it's just like logging into anything else on center. And then you'll see a little blank down here, and you can enter a comment, and your comments should just point us to what it is that you'd like more explanation about. And all of those multiple paragraphs there are kind of telling, that I don't want the bare minimum, but rather give me some context so that, first of all, I don't have to have my book next to me to understand what the nature of your question is, right? If you say, I don't understand how the author gets from 2.8 to 2.9. Well, then I got to get out my textbook and look up where those equations are, right? Tell me the physics context. And if there's some kind of cognitive dissonance that you're experiencing, like he said this earlier, and now here he seems to be saying something contradictory, what about in this example case? You can tell me about an example where it seems like he's contradicting himself or something like that. So try your best the first couple of times. I will probably come back with examples of what's good and what could probably be improved as we get past the first week of class. So try your best to just make those comments as they're assigned. Okay, let me go back to the main page. That's the first column over here. That's where you're going to post reading responses. Got to be logged in with your center credentials. The center column is for things that, we're going to do worksheets in class. Of course, we're having exams, and I will write up solutions to all of those, scan them, and post them as PDFs on there. So there will be increasing links that appear usually with the most recent stuff on top. But the only thing on there right now is the syllabus. And so if you ever lose your paper syllabus, just go there and take a look at it. And then in the right column, there's a lot of information for each date. So that's why I made this the last column. When you look at this on your phone, each column comes up one at a time, and you sort of scroll through the first column and the second and the third. The third is going to get very long. I'll always put the most recent stuff on the top so we don't have to scroll through that much. But day by day, what it is that I want you to be able to do for the, either complete on that day or for the next day. Now, some of this stuff is optional. In other words, because we went on fully online in the spring, I had 2/3 of the, kind of lectures with PowerPoints and me talking over them and illustrating things and doing example problems, all recorded in YouTube videos. And then I completed them in fall because I figured why not just do the rest of them that were from the beginning of the course. So they're all on there. And so what these videos are, so here's today, 2/8. We've got video, chapter 1, part 1. If I click on it, it takes you to YouTube, and you'll just hear me talking. You'll see the slides in front of you. You hear me talking. There'll be examples done on there. We'll talk through the material the same way we would do things in class. And so it's just a more streamlined version of what you might see in class. I'll also take breaks in there and tell you to go to a worksheet and fill out the worksheet. So the worksheets are here. If you click on this worksheet link, it should bring up a PDF of the worksheet. So if you're working at home, that's where you can get the worksheets that I'm going to be passing out in class. But here, because they're in the middle of these videos, the videos are referring to them, we're going to be doing the same worksheets in class. But if you want a second way of viewing the videos, a different presentation, that's fine. I also automatically record, should be automatically recording these Zoom meetings. And so if I can stay on top of it, we'll see how it goes. I can also post each day's Zoom video if there's something particular, maybe somebody asked a very particular homework problem and we worked it out on the board and we want to go back and go through and find where we did that. That would be fine. That is interesting. Okay. And so reading assignments are on here. So, 2.8, read 1.5 to 1.6. That sounds a little bit strange because what about 1.1 to 1.4? You're welcome to read 1.1 to 1.4. The real stuff that I want you to practice with in chapter 1 starts in 1.5 to 1.6, which is, I'll remind myself here. So 1.4 talks about measurement, uncertainty, and significant figures, and we'll talk a little bit about that. The focus of the lab we're going to do this week is on uncertainty, estimation, and a little bit on significant figures too. That's not going to be a huge focus for this lecture part, just because there's only so many things we can attack in Physics 110. We don't have that much time. And for me, the concepts that think about physics concepts like momentum, energy, mass, forces, that kind of stuff, I think those are more valuable than experimental things for your very first physics course. Section 1.5, which I'm asking you to read, units and the SI system. So it's going to be practicing with changing units, which many of you are very familiar with. We have a lot of people who are in some variety of science in this course because of the pre-health kind of connection with Physics 110. 1.6 talks about converting units. So we'll do some of that practice today or tomorrow, depending on how long I talk about this syllabus stuff. So in any case, this is what's supposed to be keeping you up to date for everything except homework. And I'll talk about homework in just a second. But let me go back to the syllabus stuff that was in PowerPoint here. All right, so I talked about the textbook. We talked about the course website. Calculators, you need some kind of calculator. It doesn't have to be super fancy. I have one of these old TI 83 plus. A lot of people have these standard issue kinds of things from high school. That's fine. Some people have Casios and some other ones. They're all fine. You won't be able to use your cell phone on an exam, of course. So you need some other standalone calculator. If some calculators, some of the higher TI number ones, are very easy to store a lot of things in, like you could store text for whole homework problems. If you have one of those calculators, which is like the TI 89 and above, I might tell you to reset your memory on your calculator before an exam. So if you don't want to do that, if you have some programs stored in there and you don't want to do that, you might need to get a calculator from a friend, or at least tell me ahead of time to make sure that I reserve a calculator for you. So if you have any questions about your calculator, certainly contact me ahead of time before the first exam. It's not going to be an issue, and it's fine with me if you use your cell phone as a calculator on homework. It is a little bit to your advantage to get used to the calculator you're going to be using on the exam and just be most familiar with them. So if you don't have one of those, these are available very inexpensively used if you know where to look for them. So, and many of you have friends who might not be using one. You might be able to borrow from them. Okay, so here's us, Young 110, our lab meeting. So I'm teaching one section of the lab. There are 4 different sections. The other ones are being taught by Professor Dr. Lauren Falco, who you'll meet if you're in her lab section. She's teaching one of the sessions tomorrow, 8 a.m., and then 2 of them on Thursday. When you go in the building, you've got to go in the Walnut Street entrance and find your way to Olin 010, which is closer to the front of the building on the left if you were facing the building. But there's just a big circle down there, so walk around until you see that room. And this Zoom meeting ID is only for my classes. So the Zoom I sent you, that's for this lecture, and it's also for my one lab session. I think Dr. Falco should be emailing with Zoom instructions for anyone who's on Zoom for her lab section. So take a look for that. Okay. There's a little blurb here on what is physics. Most people have an intuitive idea of physics, but the idea I'm trying to explain here is what do physicists really aspire to? And I love this picture that was, it's like a wood carving, ink drawing of a fanciful thing drawn by Isaac Newton, one of the most famous physicists, and it's showing like an impossibly tall mountain. Mount Everest, if you look at the Earth edge on, you would hardly see Mount Everest sticking up even the tiniest bit. So this is a fictional mountain sticking way up into the atmosphere from Earth. Weird. Oh, there we go. Sticking way up. And we're imagining someone's throwing a rock, first of all, at a low speed, and it just arcs down to the ground. Then they throw it faster and faster. And pretty soon, if they throw it fast enough, it goes into orbit around the Earth. The same way the moon orbits around Earth, or Earth orbits around stars. And this is, physicists aspire to ways of describing phenomena that connect different ways of thinking about things. So, in the days before this, people thought of gravity as something that happened here on Earth. When they looked up at the stars in the heavens, they saw the planets moving, they thought of that as a totally separate field of science. And then both of them were well developed. And this description here is Newton describing that, at least giving you a picture of both ways. And through a lot of work and the development of the calculus, he was able to describe it very concretely using mathematics. Dates to remember. Okay, so here are, I think these are fairly firm. For big classes, I don't like to change our exam dates. So I'm going to try, unless there's some disaster that I didn't foresee, I'm going to try to stick to these exam dates in this class. So these are our interim exams, March 3rd, March 31st, and April 28th. Says it's tentative. We'll try, unless there's some disaster I didn't plan for. Instead of spring break, my understanding is we have 2 break days. I assume you guys all know about that, right? So those are in the schedule. I'm not even sure what day of the week they're on. They're in the middle of the week, or is it 3 Wednesdays? Okay. And then, here's our final exam. I looked it up on the registrar's website, but triple check it for me. Don't take my word for it. I could have been crazy when I wrote this down. So check the registrar's website when finals come up to make sure we have the correct time, correct day. It will be in, well, I think it will be in this room, but I don't really know, because we were originally assigned to be in Olin Hall, and now the first floor of Olin isn't open yet. And I'm not sure if when it opens, we will be told to move over to Olin. I'm kind of hoping we don't, because our room over there has a smaller capacity, which means more people are going to have to be cycling through remote. So we'll just see what happens when that comes to pass. Hope for the best. Here is how I'm going to calculate a score on which your grade will be based. Okay, so the 3 interim exams are worth 16% each. Sometimes people sort of gasp when they see the final exam is worth 25%, but I like to have a lot of room to move at the end rather than being locked in at the beginning. A lot of times people in physics, they're not used to taking a physics course. You can falter on that first exam, and you don't want that to carry too much momentum going forward, to use a physics term, in terms of your grades. So this gives a lot of flexibility that way. Homework's 10%. I'll talk about we have a homework website that you're going to need to sign up for. That's going to count for 10% of your grade. It just keeps track of the fraction of the points you have, and I just take that fraction of the 10% in calculating your score. Website participation, this 5% here, is your posting on the readings. Okay, so usually what I'll ask for you to do is read some sections the day before we are going to talk about them. And that means you've had a some association with them. And then when we get into class, I'll give a little summary of them. We'll do a lot of problem solving associated with it. And so it won't be a totally new thing when you get to class. I like to see those postings the day before. Now, someone last semester said, I've always had it due at midnight the day before the lecture, or the midnight before the lecture. And someone said, students tend to stay up pretty late, and midnight's a little bit early. It's fine with me if you post it by 3 a.m. I probably want it posted by 5 a.m. at the latest, because I do look at them that morning before I come in, and I grab some of the most interesting ones and throw them into the PowerPoints, and we can sometimes talk about them. They can be conversation starters, or especially things where I see 8 people have the same kind of question about it. That's something that's worth talking about. So I like to have them when I come in the morning. That's the first thing I do, is look at the reading responses for that day and try to integrate them into the lecture. So it will say by midnight. I may adjust that. Certainly if you post them that night before 5 a.m. the next morning, that's fine by me. I'm not going to count them as late. And if you want me to put that in writing on the website, certainly will. Short presentation, I'll talk about a little bit later that you're going to give one very short presentation. It's only because the class is so big, we can't have very long presentations or it takes up a huge amount of time in class. And though oral communication is a little bit of an emphasis in this class, it's not something that is the main focus of this class. So each of you is going to give a short presentation. I will probably allow you to do it in groups of 2 if you want. So you can either do it by yourself, or if you want to join up with someone else in the class, you can do it as a group of 2. There's no discount on your grade or anything if you do it with someone else. That just eases up on the number of presentations we have. I'll talk about that in just a minute, and I'll give you more details on it later on. For most Physics 110 students, this has no effect on your grade, but there is the occasional, 0.5% of the time I find a student who just can't make it to class, or who is habitually tardy every day, and it just becomes an interruption for the class. So if you're that student, you're going to find that this adds up. 1% deduction for each unexcused absence. And we'll talk about what excused means. Most of you know the common excused absences. So if something happens, please talk to me, because I know sometimes in COVID times, lunch times might be spread out. You might have a hard lunch. Shouldn't be have a hard time getting here from lunch, but if something's causing you to be late to class or to miss, don't let me guess about it. Just tell me, because I don't want that to have an impact on anyone's grade unless it really is their own fault for coming late. And like I said, that really doesn't affect hardly anyone's grade in this class, but I have had a couple of problem cases. That's why I put it in there, just as a motivation for not doing that. And then the grades, nominally are based on just the traditional. The A range is 90%. Your score is 90% of the points according to those weights I've done. B range is 80 to 90 and so on. I reserve the right to be more lenient than that. It may be that I make an exam that's just, I get creative and it ends up being way too hard, and the class as a whole has a really hard time with it. And if that's the case, I may find at the end that when I look at the verbal descriptions of centers grades, excellent, I think very good is the B range, satisfactory is the C range, and I don't think it lines up with what I've seen the names are going with the different grades. I reserve the right to be more lenient, but these are sort of a guarantee. If you calculate your grade, keep track of the points you've had all along, you calculate it, you're guaranteed to get this grade at least. Okay, excused absence. That usually means one of 3 things. A center sports event. We have lots of sports going on because of fall. Illness. Illness is always excused. You just need to communicate with me that you were ill. If you're not terribly ill, it's just nice to know before class. So if you can send an email, that's fine. If you're deathly ill, just tell me as soon as you can about where you are. I just don't like to guess where people are and just have them disappear from the course. So if you're ill, definitely let me know any way you can. And if you're ill during an exam, I think that's the kind of thing where the health center person would have to kind of communicate something that you missed an exam or something like that. And the third thing, which rarely happens, is sometimes students go to a conference and the associate dean says, oh yeah, it's okay if you miss a day of class to go to this conference. So if that's the case, the associate dean communicates with me. Unexcused absences means anything else. You were told an all-nighter and you couldn't get up, or your alarm malfunctioned or anything like that. So if that is happening once, it's just such a small thing, it's not going to affect your grade. But if it happens 10 times during the term, that's going to add up to 10%. That'll bring you down a whole grade range. So don't let it get to that point. If you're having a problem and it's outside of your control, definitely come and tell me about it, and we'll make it work, make an exception for it. I just need to know. But if all else, don't not communicate with me. Tardiness is treated as an unexcused absence. Again, for center students, generally this is not a problem at all, but occasionally you just have a student who's always getting coffee before class, comes in with hot coffee and a bagel, and 10 minutes late to class. I've had those students before, so don't let that, if you're tardy once, you know, sometimes things are outside your control, just let me know and I'll just write it off for that day. But after that, it's going to start hurting unless we come to some other agreement because it's something outside your control. Okay, what about these short presentations? So, and I apologize, normally I don't just give a monologue for every day. We're going to be working on stuff, worksheets in class. You're going to be voting on things. We'll talk about that in a little bit, but today there's just a lot of stuff to explain what's on the syllabus so you know where we're coming from. So there are two general education curricula sort of in effect right now because we're switching the general education at Center College. The students who started this year are the first ones and the new ones in the new system. And so we're supposed to be covering both of them, but this is one of them that's in that most of you are under, that is in the old system, it used to be in the catalog, it's not anymore. That a general education course should develop an understanding of some of the concepts and tools of physics. Of course, we're going to do that. That's natural. Oral or written communication and creative or critical thinking. We're going to do a tiny bit of writing in the lab. So we're certainly not going to focus on written communication here. You're not going to become a great writer because of physics one time. We'll talk a little bit in the lab about maybe writing abstracts and really short things associated with scientific documents, but not a whole lot of writing practice. But for the oral part, we're going to be doing these little mini presentations. And as much as you might learn from your own, you can learn much, much more by watching other people give oral presentations. Every time I see a whole bunch of presentations in a row, I think to myself, that's a great idea. I can't forget to do that. I'm going to use that in my next talk. Or never do that because that was a total bomb. I mean, I'm sure you've all seen things like that where you tell yourself, never, ever, ever do what I saw this person just do because they lost the whole audience right there. Even sort of more perhaps seemingly afield is the recognition of connections to wider social issues, personal choices, and values. Now that's a pretty wide statement, but it's not the traditional kind of range of things that you're going to find in a physics textbook. It's not going to, you know, emphasize what things mean to you, how society feels about them, but we're supposed to emphasize them to some degree in this course. And we will see some connections with these. You know, when we talk about gravity, we'll talk a little bit about the historical view of what our place is in the cosmos and models of the universe that people had in, you know, among the ancients and how those developed. But in order to have this connect with scientific concepts kind of throughout the course, I decided to have you present, again, either by yourself or in a group of two, something that is of interest or importance or concern to you. And it has to touch one of these kind of three areas. You know, a lot of times we have a lot of pre-health students in here. So a lot of students make a connection between something in physics, and it doesn't have to be something we talk about in this course. It could be the wider area of physics or even science is fine. You know, people have talked about ultrasound scanning or various injuries that they've had because they're student athletes, things that mean something to you personally in your life. And it's a lot of fun for everyone, especially me, to see things about your life that I might not get from the physics context. Okay, social issues, it might be something related to the environment or something like that. Whatever floats your boat, it's kind of up to you. And we'll talk more about those probably just to get things rolling. I won't mention it this week, and early next week, I'll hand out something that tells you a lot more about it, and then we'll do signups and start getting into them. So think about, if you're someone who doesn't like oral presentations, a lot of times the best thing to do is to sign up for one of the very first ones and just get it done. That's what I would like to do when I was a student. But you'll get more information on that. So that's that little 2%. It's hardly worth anything in the course, but you just got to do it, okay? And the only real requirements are that it has some connection to science and has a connection to personal values or societal concerns, that kind of stuff. So, and I'm happy to talk about it if you're not sure if yours is enough of a connection or not. I'm pretty lenient about it. Even I've had philosophy majors talk about connections between philosophy and physics. That's a personal thing. You know, if you're a philosopher, that's definitely personal to you, just like a sports connection would be. This next class participation and preparation is basically saying you need to read the stuff before you come to class. Hearing it once is not enough. You need to hear it presented by the author of the book and by me, different ways of hearing it. And that will help make our class time more productive. But the second paragraph says to encourage you in this, I'm going to ask you to do website postings. And so the idea is, part of it is to encourage you to actually do the reading because you're getting the points for doing that and getting those reading postings ahead of time. But it also helps me make a more, a discussion the next day that will be more meaningful to you, at least in the statistical sense. I can't answer nearly every question, but if I see a lot of them in the same ballpark, or if I think, wow, that's a really good question, let's dig into that a little bit, I'll throw them on the PowerPoint the morning of. Extra help. There will be some kind of tutors this semester. I'm not sure. Typically, they've been in Olin or Young before, but there's some sort of new tutoring / other stuff going on in the library that maybe you've heard about. I haven't even been in the new library. I guess they're open for business now. Yeah, stop in there. There's a bagel place, but there's some sort of learning center where it's supposed to be peer mentors, and maybe the tutors are going to be in there. I'm not really sure, but I will tell you, probably this will be organized by next week. We'll have students, if the past is any indication, 5 nights a week, probably Sunday through Thursday for an hour. And sometimes they can stay a little bit longer if there's a lot of business. They tend to be underutilized. So if you, and there's usually a different student on every night of the week. So I always tell people, you didn't like Tuesday, try Wednesday. Maybe you'll love the tutors on Wednesday. They're students, usually upper level physics majors, and physics majors aren't always known for their personal gregariousness or whatever. So you just got to shop around. Some of them are very good at explaining. If you have a disability that needs accommodation, or if you have a medical condition that I should be aware of, in other words, if you might pass out in the middle of class, even if it's a rare possibility, I should probably know what's the next thing I should do if that happens. If you have a disability that requires accommodation, either for exams or because you can't hear or see well and you need to be in a certain location for class, certainly let me know about that, and we will usually, for those, you go through Dr. Brian Cusado, and he gives an accommodation notice that shows me exactly what kind of accommodation is required, and then we work it out together. So talk to him if you haven't already, if you have a disability that way. Academic honesty. There's some stuff about cheating here, and I guess it's even more important because we have a fair number of students who are remote. If at all possible, you should be taking the exam in class, but we might even be in a situation where we are in a smaller room, and a fair number of you need to take them remotely. And so your academic honesty in terms of not using resources that you're not supposed to be using on the exam is of the utmost importance. Homework is a little bit of an exception there. So it says, cheating is presenting someone else's work as if it's your own. On an exam, you grab something from the web, or you talk to Uncle Jeb, who's a physicist, or whatever. But on homework, I really encourage you to work together in completing the homework assignments. And I don't consider that cheating at all. The real dividing line is you should not write down or enter anything. We're going to be using an online homework system, so you'd be entering it in on there. You shouldn't enter in anything that you don't know how to do yourself. Okay, it doesn't matter if you got to know how to do it in a group, but you should come to the point where you understand how to do it yourself before you enter that in the homework system. Certainly, at the very least, it's going to come back to bite you in a major way on the exams, and the exams count for quite a bit in this course. So it's not worth getting those couple extra points on the homework and then not doing well on the exam. So make sure you understand all those problems. Okay, The homework system, probably almost no one has used this homework system before, and I switched to it because, the big two, which are WebAssign and Mastering Physics, I think our book is partnered with Mastering Physics, they all of a sudden jacked the prices way up. So it was over $100 per student per semester, whereas it had been like $30 or $40 a couple of years ago. So I switched to this one called Quest Learning and Assessment, which is run out of the University of Texas. And actually, the feedback I've gotten from students in the last couple of semesters is they like it better. It's more well run than the big two. And their customer service is really personal. Like if I email them, they respond that afternoon. Whereas if you email WebAssign, don't expect anything for a week or so. They're not going to respond to you in any timely fashion. The downside is it's sort of unfamiliar to you, so we just got to kind of get used to it. And there are a couple startup things that I put in a large font down here. I know my syllabus is kind of a micro font. I used to try to fit it on one page front and back just to be efficient, but with the extra COVID notes, it's spilled onto a third page, even in my small font. To get started, what you should be doing in the next day or two is trying to get a UT, that's University of Texas, EID, I don't know, electronic ID or something like that. The details about how to do that are up here. The link is down here, but it's also in your syllabus. Okay, so if you click on that, it should, hopefully this is still a current, yeah, it's still a current link. Get a UT EID. And it's going through the process of, if you ever apply to the University of Texas, it wants to make sure it doesn't double assign you one, but it's going to give you a number that you can, basically the login information. Okay, then you're going to enroll in our course, and you need a unique ID to do that. So I chose 100101. And so when you're on there, there's going to be, when you start following the instructions, and there's a lot of details here in these first couple of paragraphs, there's going to be a place to insert that unique ID. Now, it may not be unique. There may be 3 courses that have those in the United States, but you'll see one of them is Center College Physics 110, Spring 2021. And so hopefully it should narrow it down so that you can find it. And then you'll be in the course, and you can bookmark that page. You probably have to log in every time that you go there, but you can bookmark the page and go there, and you'll see assignments that have been assigned. Now, at this point, I don't think I've put any assignments on, but I probably will by tomorrow. So for tomorrow, just concentrate on getting that EID, UT EID, and getting ready for lab and whatnot. And you should see the first assignment, which will be on chapter 2. We only got a couple topics in chapter 1. Oh boy, it's 10 till. The clock is right. Okay. And I guess there's a lot of details down here that you should look through that talk about, every homework system. There's a question of how precise you're, or at least, how close you have to be to the exact answer in order to get credit. So details about that are given in those paragraphs there, as well as how to answer different questions in different formats. The lion's share of them will be in decimal format. So the answer space might be, you're giving a mass in kilograms, and it will almost always give you the units that it wants it in, and you're supposed to, give something like 2.03 or something like that. Generally, if you give 3 significant digits and all of them are correct, I think that's enough. So if you round to that 3rd significant digit, that means starting with the first non-zero one, that's 1, 2, 3. We'll talk about significant figures shortly. But occasionally, and we'll forget about this, but if you can remember, it's in the syllabus, you might have to use scientific notation, right? We're going to talk about gravity, and masses get really big. And if you talk about the mass of the Earth, what is it, like 10 to the 26th or 27 kilograms, right? You don't want to write that in decimal notation because you're going to have a whole lot of zeros. So you might do something, I think you just use the lowercase e, like 2.06. If you want to write times 10 to the 27th kilograms, you would type it in as 2.06 E27. Some of you may be familiar with that from calculator notation. The calculator uses the E in there. You can put a minus sign in front of the 27 if it's a negative exponent. We'll talk about those, but those details are in the syllabus. So when you get to chapter 5 and you've forgotten about it, try to remember it's there in the syllabus. Questions about the syllabus? I see we're not going to get to any chapter 1 stuff. We have a couple more other just random topics to explain things of why we're doing things a certain way in the course. Many of you are probably bio majors, and everybody knows learning means you're making changes in your brain, right? No surprise to anyone. You're changing those neural connections. That requires rewiring neural pathways, and not every way of sitting in a classroom is as good as every other for rewiring those neural pathways. So we want to do the way that does it most efficiently, and that is we need interactive or active engagement by you. And that means what I'm doing right now is the absolute worst way to learn physics. You sitting there, maybe taking a few notes and just listening. It means that you've actually got to do things. Speak up. I listed a bunch of things. Actively doing, asking, calculating, sketching, cross-checking my answer, cross-checking the answer on your homework to see that 2 different ways make the same kind of answer. Explaining in class, challenging other people's explanations, being challenged. You learn a lot by being challenged. Defending your point, arguing a point, taking a stand, changing your mind, summarizing, inventing a new way and carefully documenting why it's better than what the author said or what I said. All of those are great ways to learn, but it does not mean listening to me explain or merely taking notes. Okay, why am I telling you this? That's probably familiar to a lot of you. It's because we're going to do these voting questions, and many of you have done kind of clicker questions before, where you're in high school. Some people here at the center do clicker questions. There are a few reasons I don't really like clickers as much as these old-fashioned voting cards. So I'm going to pass out voting cards, and you're going to keep this with you for the semester. And sometimes twice a day, sometimes 5 times. It just depends on how many questions I have. I'm going to ask you to vote, and you have 8 responses on here. Either A through H or 1 through 8. It accommodates all of them. The virtue for me are several compared to clickers. One is, I tried the clickers before. There's always a couple of people who are like, I'll click C. I just, if I don't click anything, he's going to start bugging me. Where's clicker 21? So with these, what we're going to do is, so you're going to take this and fold it in half and fold it in half again. So only one color goes at once. And you got to find a place in your stuff where you won't lose it, because you're going to use the same one for the whole semester. So you're going to have to open it up and fold it. So let's imagine that I believe I give this question. You're not supposed to know the answer to this right now, but this is the kind of thing you might see. Diagram depicts a block sliding along a frictionless ramp. So somebody lets it go down this icy ramp, and then it launches off the edge of the ramp. And here it is at the highest point on its trajectory through the air. The 8 numbered arrows in the diagram represent directions to be referred to in answering. Okay, that's a lot of arrows. The direction of the acceleration, we're going to talk a lot about acceleration at the beginning of the course, of the block. After leaving the ramp at position R, that's when it's at the top of its motion there, is best represented by which of the arrows in the diagram. So let's imagine I choose arrow 3. That would be B in here, right? It's the choice associated with arrow 3. What I'm going to do is give you, a couple of, not a minute, but maybe 30 seconds for this one. Some of them I'll give you longer. You need to do a calculation. Although most of these things, you don't need to even really calculate anything that you can't do in your head. You might need to multiply 2 times 3, but you're not going to have to do much more than that. If I believe 2 is the correct answer, I said ready to vote. What I want you to do is show this to me in a way that shows it to me, but you're not advertising it to everyone else in the room. In other words, if you don't know what's going on, I don't want you to have to advertise to everyone that you have no idea what's going on, but I do want to know. In other words, I want to know if you're randomly guessing on these over and over again, which is usually what I don't see in the moment when people are using clickers. I just get the statistics, the bar graph, and I don't really know who's having problems. Whereas if you hold these up, so what I will usually do is ready to vote? Okay, vote. And what I want you to do is just sort of hold it up here. You don't have to hold it way up in the air, but hold it facing the front of the room. And to me, I get an instant view. I don't need to see the bar graph because if they're all green, and green is the right answer, right? This one time needs to be yellow. If I'm the only yellow in the room and my yellow is wrong, I sort of make a mental note about, well, maybe we need to talk about that, but if everybody else is on the same page, we probably won't stop. If it's a random rainbow of colors, that means nobody has any idea which way to go. That means we're going to back up and talk about it all as a group together. And the most interesting case is when half of them are one color and half of them are the other color. And that's the case where we can have a really interesting conversation with a neighbor. So I will usually say, find someone adjacent to you who voted differently than you. So you're just going to have to say what you voted and discuss for a couple of minutes, and we'll do a revote. And then we'll see if people can explain what the difference between those two answers are. But for right now, we're not going to do anything with this. 2 more minutes left. I tend to I don't know if you guys are familiar with the concept of growth mindset versus fixed mindset. Growth mindset means I know that if I keep working at something, I'm going to keep making gains. They won't always be linear. In other words, sometimes it might feel like I'm working for a while and I won't make gains. But it's the mindset of you just need to keep trying and you're going to succeed. Whereas a fixed mindset is, somebody tell me what fixed mindset means. I'm sure these are out there in the world now. Yes.
Saying something like I'm bad at physics.
Yeah, I'm bad at physics, or even I'm good at physics, right? Everybody knows why I'm bad at physics could be bad for your experience in this class because you're always feeling like, oh, I'm not good enough. I hate holding up that card because everybody can see it. But if I say I'm good at physics, that can also be bad because that means if I falter a little bit, I start questioning that I'm good in physics, and that can take the whole thing down. Whereas if I believe that the more effort I put in, the farther I'll get. So here's some famous quotes, and I'll put these in every once in a while, although I sort of fall off once people start doing the presentations because those take up the time at the beginning of the class. I try to put them on at the beginning. It's not that I'm so smart, it's just that I stay with problems longer. Albert Einstein, famous physicist. He's probably surpassed Isaac Newton in fame for physics. Do not judge me by my successes, judge me by how many times I fell down and got back up again. Nelson Mandela, trying over and over again. A genius. For 37 years, I've practiced 14 hours a day, and now they call me a genius. Pablo de Sarasate. I think he's a violinist. I'm don't necessarily know. And I think Eddie Cantor is some sort of musician or performer too. It takes 20 years to make an overnight success. All of these are saying, these are famous people saying, don't be deluded and think someone's an overnight success. They're not. They worked on it forever. It's just they were discovered all of a sudden, or suddenly something happened, but it was because of the 20 years of preparation. So it's the same way in here. If you're having trouble, don't get discouraged. Just take the next logical step, whether that's coming to office hours, calling up a friend or texting them and getting together to work together. But don't feel alone like it's your fault. It's not your fault from a growth mindset. The only fault is if you don't get up and take that one next step. All right, 4 o'clock. Any questions? Sorry we didn't get into the material, but we will certainly do that on Wednesday. Maybe I'll see a few of you tomorrow in my lab section. Otherwise,